Picture two neutron stars, each heavier than our sun, yet no bigger than a city, locked in a death spiral. For years, what happened when these cosmic titans collided was pure speculation. Now, thanks to a groundbreaking simulation on Japan's Fugaku supercomputer, we can witness this cataclysm in unprecedented detail. In just 1.5 simulated seconds, gravity warps space-time, sending out gravitational waves, the universe's most powerful ripples. This digital experiment reveals the final moments, a frantic spiral, a collision, and the birth of something even stranger, a black hole. For the first time, we see the true violence and beauty of the universe's most extreme event. As the neutron stars merge, matter is torn apart and transformed in a cosmic forge. Temperatures and pressures soar, breaking atoms into a soup of fundamental particles. Here, the R process begins. Atomic nuclei bombarded by neutrons, forging heavy elements, like gold and platinum, in an instant. The simulation shows how these precious metals are created and scattered across the galaxy. Neutrinos flood out, carrying energy and clues for astronomers searching for these events. Magnetic fields twist and intensify, storing up energy for the next act. This is the universe's ultimate alchemy. Creation born from chaos. The merged mass collapses under its own gravity, birthing a black hole in a fraction of a second. A disk of superheated matter orbits the newborn black hole, fueling a spectacular finale. Magnetic fields and the black hole's spin launch jets of particles at nearly light speed. Gamma-ray bursts that outshine entire galaxies. The simulation finally reveals how these cosmic explosions are triggered, solving a long-standing astrophysical mystery. We witness the engine of a gamma-ray burst being built and unleashed before our eyes. This simulation is more than a visual spectacle. It's a key to understanding the universe. By predicting the signals of light, neutrinos, and heavy elements, it guides astronomers in decoding real cosmic events. Multi-messenger astronomy now connects gravitational waves, light, and particles into a single story. We see how the universe's most violent moments create the elements that make up our world. With each new simulation, we get closer to unraveling the universe's deepest secrets. For the first time, we truly have a front row seat to the cosmos's most spectacular show.